Okay, so we've answered question or hypothesis 2 already, because that was just really part of the analysis that we already ran. So third hypothesis, that there will be an interaction between treatment, program, and gender on the change in reading achievement scores. Okay. So what are we doing here? Factorial ANOVA, and what are independent variables? Okay, good. Treatment program and gender. How many levels of treatment program do we have? 3. Medication, behavior, and combined. And how many levels of gender do we have? 2. Good. Okay. And it's asking for the dependent variable to be what? Achievement scores? Just achievement scores? Change in reading achievement scores. Yes. That's what I was just thinking. Do I even have a pre and a post achievement score? No, I don't. This is what happens when you create the data set, right? Add this stuff to the data set right before you come to class. Okay. All right, so let's show you how to generate random data and build in a little bit of a result. How about that? Okay. Okay, so we're going to make the one that's already here be the pre-reading achievement. Okay, and we're going to create a post-reading achievement. So transform, compute, post-achievement. Okay, and then in this function group, come down to random numbers. And then we're going to come down to rv.normal, which means random variable generated in a normal distribution. Now, keep in mind that these are random numbers, so we're going to likely all get different things. Okay. So you're going to hit rv.normal and stick it up top. And let me see what. Okay, so it looks like probably I generated achievement on a scale with a mean of 100 and a standard deviation of 15 is probably what I did. So if we wanted it to be completely random, we could just in here put 100-15. That would, it basically randomly samples variables from a normal distribution where the mean is 100 and the standard deviation is 15. But I want to try to build in a little bit of a result. So instead of doing that, I'm going to actually say, I'm going to put my thing over here. I'm going to go get my achievement score. I think that's it. And stick it over there. So I'm going to take pre-treatment achievement score plus a random number, the mean of 10, and a standard deviation of 3. So I'm going to say, like, add about 10 points to everybody's achievement test score, but don't just add 10 points. Like, add some, pick a number that is on a normal distribution with a mean of 10 and a standard deviation of 3 and add it to that pre-treatment achievement score. Okay, so I'm trying to kind of build in improvement, but I don't want everybody to improve the exact same amount, and probably some people are going to get worse because there can be numbers bigger than 10 that get added to their or subtracted from their thing. Okay. And press OK. And go and check your data over here. Okay, so we have a post-test achievement score. And I'm going to see if I rounded off this pre-achievement or not. I didn't. Okay, so we're going to subtract. We're going to create our difference achievement, and then we'll round the difference. Do you remember how to create the difference? So you're creating an achievement difference. Okay, and here we're going to be fancy and do all this in one step. We're going to round And then what do we want to round? You know what? I'm gonna subtract post minus pre, so that the differences will be positive. Okay. Yeah. And I expect that they will get better. So post achievement minus pre achievement, and we're rounding that. Is everybody there? Yeah. So put the round function and then do post achievement minus pre achievement. Everybody there? And press OK. All right. Yeah. So you guys probably don't have the same numbers as I do. Do you? Okay. So it's in the random data sets, it starts at a it picks a seed number and then it follows a program. So if this is the first time we've all done it in this thing, it might have picked the same seed number. Does everybody have the same numbers? Does everybody has 7 for their achievement difference score for the first one? Good. That'll make it easier to interpret the results. Yeah. So now what is our analysis? So there'll be an interaction between treatment program and gender on the change in reading achievement scores. Very good. So analyze what? You can press reset down here if you want to get rid of everything and just kind of start over. What's our dependent variable? Okay, so it should be the last thing, ADHD diff. No, sorry, it's achievement diff. Where is achievement diff? There we go. Don't know why it's saying it's a. And what are our fixed factors? Was it treatment and gender? Again, check your model. Make sure it says full factorial. It's the default once you put in an extra variable, so it should. And then we want to plot, so plot. You could do it either way most of the time. Let's do it the same way so our graphs look the same. Yes. So what probably makes most sense to people is treatment on the horizontal line and then gender on separate lines. Remember to press add or it won't give you the plot. Puts it down there. And then press continue. And okay. Okay. So is there a significant main effect to treatment? No. Is there a significant main effect to gender? Is there an interaction? Nope. So none of that's significant. Let's see what our plot looks like. Interesting plot. Okay, but they don't cross, and I guess this pattern they're saying is not enough to be considered an interaction because it's a different pattern, sort of. And look, I mean, look, I know it looks real different from the chart, but look at the numbers over here. I mean, that's 9 and that's 10. Yeah, so it's kind of tricky. Not ADHD difference. We got a significant difference across treatments on ADHD difference, but not on achievement.